which turned the art of dogfighting into a science. Colonel Boyd works with mathematician Thomas Christie to develop the now famous energy maneuverability theory. This groundbreaking work enables fighter pilots to evaluate their energy potential at any altitude and in any maneuver, as well as the energy potential of their aerial adversary. Colonel Boyd goes on to show how his theory can be used as an effective tool for designing new fighter aircraft. The approach emphasizes an aircraft capable of quick changes in speed, altitude, and direction. Boyd and a group of like-minded innovators form a small advocacy group within the U.S. Air Force, dubbed the Lightweight Fighter Mafia. They conceived the Lightweight Fighter program, and in 1969, they secure funding from the Air Force to validate their theory. General Dynamics receives $149,000 and Northrop $100,000 to develop design concepts that embody Boyd's energy maneuverability theory for a small, low-drag, lightweight, pure fighter. The concept gains political support from the Deputy Secretary of Defense. In May 1971, he establishes an Air Force prototype study group, which will fund 2 of the proposals. And on the 6th of June 1972, the U.S. Defense Department seeks submissions from the aviation industry. 5 companies respond, and in March, the Air Staff announces that the winners for the prototype development and testing phase are Northrop and General Dynamics. Northrop works in collaboration with McDonnell Douglas to design a twin-engine lightweight fighter that employs 2 separate tail fins, giving it an appearance similar to the F-15. The design is given the Air Force prefix YF-17, and they place an order for 2 prototypes. The General Dynamics concept employs a single-engine design of the same type used in the twin-engine F-15. Many late Western designs offer 2 power plants as a safeguard against engine failure, but General Dynamics wages a lot on the excellent reputation of the Pratt & Whitney F-100 engine. The Pratt & Whitney F-100 turbofan delivers 23,450 pounds of thrust and reduces the weight of the aircraft by 3,740 pounds. The model is designated the YF-16, and 2 prototypes are ordered. Both companies are given contracts of over $30 million to produce the competing models. In January 1974, General Dynamics delivers the first YF-16 to Edwards Air Force Base in California, and the first official flight is to commence on February 2nd. But the first actual flight occurs accidentally during a high-speed taxi test on January 21st. While gathering speed, a fin scrapes the ground and the aircraft begins to veer off the runway. The test pilot lifts off to avoid wrecking the machine and safely lands it 6 minutes later. Northrop completes the YF-17 design in June 1974, and after testing, competes in a flyover alongside the YF-16 as part of the decision-making process to resolve which concept will win. Belgium, Denmark, Norway, and the Netherlands form the Multinational Fighter Program Group to select a replacement for their aging F-104 starfighters. They indicate that the winner of the lightweight fighter contest will be the favored candidate. In September, the Air Force announces that they plan to purchase 650 of whichever aircraft is chosen for the air combat fighter. In January, the Air Force announces the selection of the YF-16. It is the overall performance of the F-16 prototypes that impressed the Department of Defense. A pre-production order of 15 aircraft is placed, with the prospect to purchase 650 aircraft over the next 5 years. But Northrop's design is not scrapped forever. The YF-17 would eventually evolve into the F/A-18 Hornet. The Hornet is an all-weather, carrier-capable, multi-role fighter jet, designed to attack both ground and air targets. F-16s joined the Iraq War in 2003 and are still active in counterinsurgency missions. The Fighting Falcon's most famous involvement in the war was the 2006 strike that assassinated Abu Musab al-Zarqawi, the then leader of Al-Qaeda in Iraq. The U.S. Air Force names General Dynamics prototype, the YF-16, winner of the Air Combat Fighter competition in January 1975. The flight test program reveals the YF-16's superior acceleration, climb rates, endurance, and turning ability. During development, both manufacturers are aware that the aging F-104 Starfighter will soon need to be replaced. The F-104 equips several European NATO air forces, so the replacement will be the fighter deal of the century. In May 1975, the prototype makes its first transatlantic flight for a sales tour to potential NATO customers. The Paris Air Show offers an ideal opportunity to display the YF-16's ability to European clients. At the air show, General Dynamics chief test pilot Neil Anderson thrills the crowd and impresses experts with the red, white, and blue lightweight fighter. Many countries have been studying the design for some time. They are looking for a replacement European fighter that offers economy without sacrificing performance. After intense international competition among manufacturers, NATO countries adopt the General Dynamics design. By the end of the air show, 4 European air forces sign up for 348 F-16s. With substantial orders on hand, General Dynamics' Fort Worth plant goes into top gear, and the first F-16 single-seat model rolls out in December 1976 for testing. When the plane is built, it represents the last word in technological design. At about 18,000 pounds, the aircraft is extremely lightweight, thanks to the use of advanced aluminum alloys. The cockpit has several features not seen in earlier fighters. Provisions are made to reduce stress forces on pilots as their F-16s maneuver. Sharp turns and sudden accelerations can put the pilot's body under severe stress from the forces of gravity, or G-forces. Higher G-forces cause problems with blood circulation and present a serious threat to the pilot. At 2 Gs, the pilot begins to lose peripheral vision, and by 6, he's in danger of blacking out. To improve the pilot's tolerance of G-forces, the seat is laid back at an angle of 30 degrees. This distributes the pilot's weight over a greater area and creates pressure for blood to return to the heart. The cockpit layout makes information readily available to enhance the pilot's situational awareness. The heads-up display, or HUD, projects visual flight and combat information onto the weapon sight glass directly in front of the pilot, without obstructing his view. The design also places controls at the pilot's fingertips, so during a fight, he never needs to look down into the cockpit. For easy and accurate control of the aircraft during high-G combat maneuvers, the side stick controller is used instead of the conventional center-mounted stick. So talk to me a little bit about the evolution of the flight control system in the jet, specifically the stick. When it first came out as a new concept, did the guys that were flying it like it, or was it kind of foreign to them?
Well, it was truly foreign. It was a side stick, which was different from any airplane before it, the F-15 or the F-4. And the stick didn't have any movement at all in it. It was fixed. It took inputs based on pressure alone.
No movement.
No movement, and the pilots didn't like that.
Did that end up making it easier to fly, more difficult to fly? Did it lighten the workload for the guy in the cockpit?
It was a lot more sensitive control. And you get into what they call roll ratcheting, where you put what used to have been the right amount of input into a lateral move of the jet, but you would give too much and you would overcorrect. And it took a little bit, coming from a different background, to recalibrate your flying motor to what was the right input. But once you got used to it, it was great. It was very responsive as a fly-by-wire flight control system.
The F-16 also employs an advanced radar for search, weapons control, and guidance. General Dynamics recognizes that maximum visibility can provide a small edge that today's dogfighters need over their opponents. The one-piece bubble canopy is one of the most subtle yet beneficial features of the F-16 design. It provides 360-degree all-around visibility. The wing and fuselage blend into each other, creating a single modular unit. By having a smooth transition from wing to fuselage, the F-16 is given improved performance at high angles of attack. The phenomenal maneuverability and agility that allows the F-16 pilot to outperform all other aircraft is a result of the blending of two new sciences: fly-by-wire electrical operation of the aircraft's control surface actuators and a relaxed static stability. When both of these innovations work together with the F-16 electronics and automatic flight controls, the result puts the aircraft in a class of its own. The high-tech F-16 also uses a digital flight control concept. The flight control computer accepts the pilot's input from the stick and rudder controls and manipulates the control surfaces to produce the desired result without inducing a loss of control. They had certain advancements already by the time the F-16 was fielded, and one of them was the digital flight control concept.
F-16 was the first one to have that kind of system. The airplane was able to be designed what's called statically unstable, so that it won't fly unless it has the assistance of a computer. So a computer actually controls all the flight control surfaces on that, sending signals to the hydraulics that move those surfaces, which is a direct contrast to how all previous airplanes were done.
The F-16 is the first plane completely controlled by a computer, and many pilots call it the electric plane. It is also the first aircraft to feature a thrust-to-weight ratio greater than 1:1, providing enough power to climb and accelerate vertically at the same time. Quick turnaround speed is essential for any modern-day fighter. Its ability to land, quickly refuel, and rearm is fundamental to its effectiveness in combat. Because the manufacturers incorporate technologies that are already proven in aircraft like the F-15 and F-111, it allows designers to simplify the airplane and reduce its size, purchase price, maintenance costs, and weight. The aviation industries of the 4 participating European nations also benefit from the F-16's success through subcontracting, licensing, and ultimate assembly. The first and major assembly line is at General Dynamics plant in Fort Worth, Texas. The program is large and complex. Scale models must be used to achieve effective workflow. As production and assembly get underway, the European manufacturers also begin construction. In August 1978, the first fully operational F-16 rolls off the line and begins pre-acceptance trials. And on January 23, 1979, the United States Air Force's 388th Tactical Fighter Wing at Hill Air Force Base in Utah receives the first F-16. Hill Air Force Base holds the official naming ceremony for the new aircraft on July 21, 1980.